Okay. Oh, anyway, I'm Brian Sheron. I live in Poolsville, Maryland, which is, if you know where, well, about 30 miles northwest of Washington, D.C., or about maybe 17 miles west of Rockville, Maryland, or uh, 6 miles due east of Leesburg, Virginia. So we're out in the western part of Montgomery County in the middle of nowhere. But anyway, I model a Long Island Railroad. My current layout is a third one. I started it in 1988 when we moved into this house. So it's, you can see it's already 34 years old. And I've made a lot of changes to it over the years, so it's not been totally stagnant. But one of the things I got interested in after I kind of finished it was adding some animated stuff to it. And the first thing I wanted to really do was have some operational crossings, grade crossings, with flashers that automatically started, gates that went down and stuff when a train approached. And so I started doing some research on it to find out what was out there. Just from background, as you know, roadways frequently have to cross railroad tracks at grade, although there's a lot of effort right now to eliminate grade crossings. But railroads are required to put in warning devices to alert motorists and pedestrians for safety reasons, obviously, for approaching trains. Initially, up into the first quarter of the century, these crossings were basically protected by flagmen stationed at the crossings. So as the train approached, the flagman would run ahead and stop traffic while the train crossed the grade crossing. But after about the first quarter of the 20th century, they started installing automatic crossing gates and crossing flashers. Depending upon the amount of traffic, railroad traffic, as well as the amount of car traffic, you can have a simple crossbuck warning, which means you have very infrequent trains. They probably approach the crossing slow, and therefore there's plenty of time for a car to see them and make sure they're off the track. If you have something that's a little more heavily traveled, crossbucks with flashing lights and bells, although right now they're pretty much trying to put crossing gates at all crossings now. So you have a crossbuck with flashing lights and a bell, and then you have gates that automatically lower and block the road before the train arrives. And so what are we going to do with this clinic? Well, really, it's kind of to show how to install automatic operating crossbucks and crossing gates, and kind of show that it's really not that difficult to do. There are many grade crossing components that are available on the market. I'm not going to claim that I've found everything. I've looked. I'll discuss what I know is available. There may be more. So I certainly don't want to make this sound like it's all inclusive. And what I always tell people is, like, you know, with your layout, you really need to go out and see what's out there, do your own research, and see what's available and what best suits your particular needs and your budget. This stuff can run into some money. So it's really a matter of your personal desires for your layout, how much you're willing to spend, how much realism you want, etc. Here's just a typical modern Crossbuck flasher. This is one I took up at a grade crossing up in Buckystown, Maryland, which is just south of Frederick, Maryland. It's just a typical flasher and a crossing gate that'll drop when a train approaches. You know, when I started to put this clinic together, I like to kind of collect my thoughts, and I found that I could really, when you're modeling a grade crossing, there's 4 aspects to it. There's the flashers themselves on the crossbucks. Then there's the crossing gates that go up and down. There's a crossing bell. And most importantly, I think, is the detection and activation circuit that makes all this stuff work automatically. So I'm going to walk through each of these separately. With regard to all of them, there's really 2 options. One is to see if you can find an integral system. In other words, somebody that's already got all the components, the detection system, et cetera, and you just go in there and install it. The other way is you can buy separate components and you put them together and make them all work. Now, the integral system, I think, is the easiest way to install an operational grade crossing. The trouble is there's not a lot that are out there, okay? These would be an integral system that contain all the components, detectors, flashing crossbucks, bell. Now, some you can get detectors with flashing crossbucks and maybe a bell, but they're not going to have operational gates. And then there are other integral systems that will include the gates as well. There's some companies that make integral systems. I'll show you in a minute. Tyco, Lifelike, Bachmann. ZStuff or Train advertises one, but I'll be quite honest, every time I look, it's not available. Mike's Train House had an integral system. They closed, but I think the employees bought it. So they're back in business, but every time I check their website, it's not available. So I don't know whether they're still making it or just haven't resumed manufacturing it. And then Walthers has a system just for the crossbucks and the flashers, but it doesn't work on a DCC system. It only works on a DC. Now, here's your simplest and least expensive and least realistic system. We've all seen these, or maybe had them when we were kids. The train runs over, the pressure pushes down on this plate, and the gates drop. And then the minute the train gets off that plate, the gates go up. Not really very realistic or anything, but the gates go up and down. Now, Mike's Train House, they make an integral grade crossing system. It comes with operating Crossbuck Flashers, operating gates, and detectors to activate the system. And if you look at their website, it costs about $180. And it looks like that. As you can see, these big boxes here, which I think contain the drive motors for the gates, they would mount up underneath the layout. Here's the mounting tabs, and then just the crossbuck and the gate would extend above the layout. And then there are detectors that would be embedded in the track and connect up to these boxes here, which would activate the gates. And it looks like this is a speaker, which means you've got a crossing bell there. ZStuff for trains, they also advertise an integral grade crossing system, operational crossbuck and flashers and detectors, and they also had one with operating gates. Again, the availability of all this stuff is very uncertain. When you go on their website, it's not available, even though they advertise it. But I do know, I've met some people that actually have these, that did find them when they were available. So whether they're coming back, I don't know. The Walthers grade crossing controller, as I said, can only be used with a DC powered layout. I think this is because it derives power from the track. So it can't be used with DCC. And it uses optical sensors that will detect when a train goes over the optical sensor. It blocks off the light, which triggers a circuit, which would start the flashers and everything. And in the minute the train uncovers the optical sensor, the flashers would stop. And it connects to the Cornerstone grade crossing flashers that Walters also sells. So, you know, my conclusion from all that research of looking what was available in an integral system is there's not a lot. There's a couple out there, but they're not available. If you go to buy them, you're not going to find them, I don't think. So that means if you really want to put in an operational grade crossing system, you're going to have to probably get your own components and put it together. So for crossbuck flashers, most grade crossings have gates and crossbuck flashers constructed as an integral unit. That means that the gates are actually attached to the post that the crossbuck flashers are on. But they can be separate. There's nothing that says they have to be connected. They're not as common, but I think they do exist. Several manufacturers include a flasher circuit with their crossbucks, especially some of these Chinese companies. If you look on eBay, they will sell a crossbuck flasher, and they have a small flasher unit that they sell with it. It's very inexpensive. I think you can usually get 2 crossbuck flashers with the circuit for somewhere between $12 and $15. If you apply voltage to the circuit board, usually 12 volts DC, it's basically just a simple a flip-flop gate, whatever I can't remember my electronics, but basically it just starts the crossbucks flashing. Then when you take the voltage off, they stop flashing. So the trick is, how do you connect that to a train detection circuit that will automatically activate it? Somehow you got to have the 12 volts start up automatically and then go off it automatically. And this is what they look like. If you look on eBay, you'll see a lot of these under, if you just go under model trains and grade crossing flashers or grade crossing crossbucks or whatever, you'll see a bunch of these for sale from China. They're about $11.99, give or take $1. And you get usually you get two flashers, two crossbuck flashers, and this little circuit board. You put 12 volts in here, and you hook up your lights here to these ends, and that'll start them flashing. Crossing gates. There aren't a lot of scale crossing gates. When I say scale, I mean, I'm an HO, okay? So I really didn't do a lot of looking in S or O gauge or even N. But my feeling was if there wasn't a lot available in HO, there's probably not a lot available on the other scales either. But there are a few crossing gates available, and few, if any, that are combined with crossbuck flashers. Now, the company that made the most realistic ones was NJ International. They had an operating crossbuck and a gate, okay, and they were really top-notch, you know, looked very, very realistic. Trouble is that the availability is uncertain. 1 minute they're available, the next minute they're gone, everybody's out of them. If you just type in, you know, for example, Google NJ International operating crossbuck or crossing gates, you'll find a lot of companies that advertise them, and when you click on them and you go to order it, it says it's either back ordered or it's out of stock, but not available. You can occasionally, somebody puts them up on eBay. If you're lucky enough to find them, if somebody has put them up there and get them, they're not cheap. They typically, when they're new, they'll run around $55 or $60 for a pair. The last set I got was used, and it came with a Logic Rail Technologies crossing circuit, but it was about 80 bucks or so. Tomar also makes an operational crossbuck with crossing gate. Again, they are totally out. They're back ordered. Nobody has them. So basically, they're not available right now. Now, here's a picture of the NJ International crossing gate, which is on my layout. The gate arm is activated by a rod connected near the pivot that extends below the layout. I don't know if you can see my cursor here, but this is there's just a thin brass rod that hooks in to the end of the gate here. And if you, as you can see, if you pull the rod down through the layout, it'll raise the gate. If you push it up, it will drop the gate. Where am I? Oh, sorry, went the wrong way. There we are. This is just another NJ International combination crossbuck and crossing gate on my layout. So you can see these are pretty much to scale. And like I said, I think these are the nicest ones that I've seen that are available. Next one, there we are. Now this is one where I found these on eBay. These are actually NJ International crossing gates, but they don't have the crossbuck. And the crossbucks that I've used here with the flashing lights, these are from Berkshire Junction, which is up in, I think they're in New Hampshire or Massachusetts, like, or Vermont, I think. They used to go to the Timonium show and have a table there, but they haven't been there. There was an elderly couple. But they sell a system that uses infrared detectors that shine across the track, and when the train breaks the infrared beam, it'll start these flashing. And the circuit board has a relay output. There's a relay on it that you can use. And so what I did is I had to wire that up to another relay because it's only a single pole double throw relay. I had to wire it up to a double pole double throw relay, and that would be that could be used to reverse the polarity on a tortoise switch machine that I use to drive these up and down. And also it can be used to activate a crossing bell. So how else can I make a combination crossbuck flasher and crossing gate? Well, if you can't find, like I said, you know, either the integral systems or even the NJ International, what you can do is that it's not the best, it's not the most ideal, but it works, and it's not bad. Is you take the gate arm from an inexpensive crossing gate, such as like the Tyco or the Bachmann system or the Lifelike, and you get an operational crossbuck from another manufacturer, whether it's Walthers or the like the Berkshire Junction. You got to remove the gate arm and cut off the pivot mechanism from the Tyco mechanism or the Tyco or the Lifelike system. What I did is I had to file a semicircular recess in the pivot mechanism that I removed. That's about the same diameter as the crossbuck post, and that way it would glue on to the crossbuck post. And you glue it on there, and then you can reattach the gate arm. And this is the little piece I'm talking about. And here I've just kind of filed a small semicircle in these. And then as you can see, here's a crossbuck, and I've glued that pivot mechanism onto the side of it. And then here is a like a gate arm from a Bachmann. And so here's two operational crossbucks with the Tyco gate arms attached. Now the crossbuck on the left is from a Tyco system, and I basically what I did is I was fooling around and I drilled out and I put some red LEDs in there. And the crossbuck on the right is a Berkshire Junction crossbuck with a Tyco gate mounted to it. And the only thing I would point out is notice the difference in scale. The Berkshire is a lot closer to real scale, you know, HO scale than the Tyco or they're just a little, these are way too big. Okay. And then on each of them, I drilled a small hole and I attached a thin brass rod that I put on the end, and that is used to move the gate up and down from underneath the layout. Now, as I said, you can put these Tyco crossing gates, kit bash them onto more realistically scaled Crossbuck Flashers, you know, and even if you don't want to make it operational, even if you don't want to go through the hassle of trying to put motors and stuff underneath it, but just have gates there, they'll still look better, okay? They're not perfectly scaled, but they're reasonable. Now, I mean, obviously you can also scratch build your own gates and get something that's maybe a lot closer to the scale, you know, really the scale or the like. You know, so if you're so inclined, or you can 3D print them for that matter. If you're into 3D printing and stuff, I haven't done that. But I mounted gates on Berkshire Junction operating crossbucks. And here's a couple spots on my layout where I've done that. These are all operational flashers, but the gates don't operate. The reason they don't is because underneath my layout, I have a hidden loop. And the loop actually kind of follows the track on the top. And so the problem is I've got no clearance underneath where I could mount any kind of a drive mechanism because I've got a track under there, a double track. So these are just really for show. They don't go up and down when a train goes by, but the flashers do work. On this one up here, I actually have removed these and I found some NJ International gates. And so I spent about, I don't know how long putting in an operational gate system here. So these gates actually now go up and down when the train goes by. And this is just another one where the gates are for show. I leave them in the up position, you know, but the flashers still work. Now, how do we operate the gates? Well, to realistically raise and lower a crossing gate, you need a motorized turnout controller. That's probably best. You need something that's slow. You don't want to snap, you know, a switch machine or something that's you know, the magnet type where it just slams them open and shut and the like. You want it to move slow and realistically. And it's got to move slow and realistically in both directions, both up and down. And it needs to be a vertical motion, obviously. The rod that you push down through the layout is either going to be pushed up or pushed down. Now, tortoise switch machines are well suited for driving a crossing gate. But what you need to do is add a remote tortoise mount. So a switch machine motion is vertically up and down. And let me show you what I mean by that. Here's a typical Circuitron tortoise switch machine. As you can see, you know, the way they operate is this arm here swings back and forth. Whoops, I'm moving my whole picture here. All right, doesn't want to do that. So anyway, this moves back and forth. There we go. And it pivots right here, and then this rod comes up and usually goes through the tie bar on the points, and it'll move the points back and forth on a switch. But obviously that's not the vertical motion that we're looking for. Well, the tortoise makes a thing called a remote tortoise mount, and it's really designed when you have, say, a location where you want to put a switch, you want to have this thing drive a switch, but you don't have the room underneath the table. There may be something blocking it, or some bench work or something. And so what they do is they make a mount that allows you to mount the switch machine on this bracket here. It takes that swing motion back and forth and translates it into a vertical back and forth. Now this shows it as horizontal back and forth. And then they have this other mount over here. As you can see, this rod would connect through this link right here, and then that would turn. This would project up through the layout surface, and then down into either the hole in the center of the tie rod or on the part that extends out with a little hole on it. So this would actually swing back and forth and move your turnout. We don't need this part, okay, because this is what we're looking for, is this part here that just translates this back and forth motion on the tortoise into a vertical. If you turn this thing 90 degrees, you'll see that would be a nice vertical motion then. Now, they also come, if you want to have this thing run, for example, operate a semaphore, they also give you the pieces to make this mechanism. So what you do is you have a cable with a plastic sleeve that clamps at both ends, and then there's this pivot mechanism you would mount underneath. And as this goes back and forth, you can adjust the position here, and that adjusts the distance up and down that this rod goes, so you can move a semaphore. They also recommend that for operating crossing gates, but I found that it's a little, trying to get this linkage and everything and all this, and doing this on your, while you're underneath your train table, is a pain in the butt. And there's a simpler way to do it. So what I did is, the first thing is I built a mount for the tortoise machine, and I just used 3/4 inch pine. Get it in any lumber yard or anything, hardware store. And I made an L-shaped mount for the tortoise machine. As you can see, it's just a L-shape, few screws to hold it, a little bit of glue in there. Now, before I installed the tortoise machine on the mounting block, I measured what I did is I measured the distance the crossing gate actuator rod had to travel in order to move the crossing gate from the up to the down position. So actually, before I put the gate into position on the layout, I had it on the workbench, and I would pull the rod down so the gate was in the down position, and I had a ruler next to it. And then I would push the rod up until the gate was in the up position, and I would note how far did that rod have to move. Was it 1/4 of an inch, 3/8 of an inch, whatever. And once I found out how far I needed to move that rod to make the gate go from the full down to the full up position, you can adjust the pivot arm on the tortoise machine such that you can get the throw distance for that vertical rod on a tortoise machine just about the same. When you put it together, you would see on the remote tortoise mount that there are several holes on the pivot arm, and you can pick whichever one you want, and depending upon which one you pick will determine how far up and down that rod moves. So you can just experiment real quickly at the bench until you make sure you got the right distance, and then you just put the rod, you screw the pivot arm in there at the right position, and you're all set to go. What I found is usually, though, is that the tortoise pivot arm, you need to set it for the shortest throw possible. Usually it doesn't take a large distance in order to move that rod, the gates up and down. So here's the tortoise machine with the remote mount, and it's attached to the L-shaped block, which is right here. There are two parts here. Remember, this piece right here is the one that moves up and down. When the switch machine is activated, it goes up, it goes down. The rod will pass through. This is just basically a guide. So you don't screw that all the way down. You leave it slightly loose. So the rod, there's a groove in there. So the rod will ride in the groove. You keep it loose enough so the rod will slide and there, but not come out. And then you put the rod and you clamp it on this one right here. You tighten that screw down and that clamps it. So you can see what happens is when this moves down, it'll pull the rod down and the rod will be guided through that groove here up through the layout. So you're kind of looking, this is the fascia on the front of my layout. You're looking underneath. This is the bottom of the layout. Here, all I'm showing here is how I mounted that L-shaped block. Just 2 drywall screws. I got up in there with my drill. Once I had it, what you have to do is once you put your gate in there, so the brass rod's coming down, you have to have the brass rod so it's right in position with the clamps on the remote tortoise mount. As I said, fasten the mounting block with the tortoise machine to the underside of the layout. And so the actuator rod is aligned with the tortoise machine rod guide and the rod clamp. Now here's another view. Here's the mounting block. You're looking at, this is the underside of the layout. Here is the tortoise machine. Here is the remote tortoise mount. Here's the rod coming down through the layout. It goes through the guide, that groove in there, and then it clamps right here. Okay, and here are the wires coming from the Crossbuck Flashers. And so you can see when this arm moves down, it'll pull this rod down, and what that'll do is that'll make the gate go up. And then when you reverse the polarity on the tortoise machine, it'll drive the machine up, and that will drop the gates. You can also, when you're putting it in, you have to make sure, that you adjust the actuator rod so that the gates are in the right position when the machine is when this switch is either all the way up or all the way down. So here's just another one at another crossing I have. As I said, I had some bench work here from way back, and I had to build something to mount the tortoise machine and the actuator on. And so I had to make a little shim right here so I could mount the whole thing up and it was sturdy. But again, here are the here's the wire coming down through and clamping on through the groove and then into the clamp on the mechanism. And so here's with the gates up. And by the way, that's a sign I found on the internet. I thought it was pretty neat since I was doing Brooklyn. For those of you from New York, you get it. And then here is with the gates down. Now let's talk about detection systems. So in other words, what we've done now is we've talked about Crossbuck Flashers, we've talked about, crossing gates, how to build them, what we can use to make crossing gates, and how we can have tortoise machines activate them. Now, there are other machines that can activate gates. It doesn't have to be a tortoise machine. If you guys are, if anybody there is big on Arduino circuits and the like, you can program one of these things to operate a servo motor. Servo motors are a little bit cheaper than tortoise machines, along with the remote tortoise mount. So you can get by cheaper. But I looked into it a little bit, and I'll be as honest as I can. Unless you're a computer whiz bang, the Arduino uses C++ language. It is not the most intuitively or easiest language to learn. If you go on the internet, it'll tell you that if you're a beginner, it's going to take you 2 or 3 months to learn it if you work at it 2 or 3 hours a day. And that's just really to get you through the basics and stuff. So I really didn't want to get into, having to learn a whole new computer language and everything, programming language, and program an Arduino circuit. There's enough stuff available, and the price difference is minimal, really. An Arduino board, an Uno board will run you about maybe $18.99 from Amazon, and for maybe $20 more, you can get a circuit that's already been programmed and has everything on it. So anyway, so far we've discussed the availability of complete systems, Crossbuck Flashers, crossing gate drives, and so now we're going to work on detection and activation systems. Now, there are several companies that make electronic systems that will automatically activate Crossbuck Flashers, crossing gates, crossing bells when a train approaches a grade crossing. Just for some background, there's pretty much 3 ways a train you can detect when a train approaches a grade crossing. You can use a photocell, you can use an infrared emitter and detector, or you can use a current detector. Now, photocells, they usually mount between the rails, embedded in the ties. A photocell is nothing more than a resistor that changes resistance depending upon the amount of light incident upon it. So as the energy of the photons, the light that are hitting the photocell, what it does is it frees electrons to flow through the photocell material, decreasing its resistance. So it makes it easier for current to flow through a photocell. And you use that property to detect and activate a system, okay? So you have electronic circuits then that detect this decreased resistance, and you use them to trigger circuits that activate the flashers, gate motors, etc. And then obviously, when the train covers over the photocell, what happens is the resistance goes up. And so really what you're doing is you're having a system, you have an electronic system that detects when the resistance increases in the photocell, and that's what really triggers your system to drop the gates, start the flashers, etc. And then when the train uncovers the photocell and you get light back on it, then it would make the flashers stop. It would raise the gates, etc. This, however, does require room lighting. You have to have lights in the room. So if you're doing night scenes, if you got lights in your buildings and you want to do night scenes, they're not going to work in a darkened room. It's going to look like a train went over it, and that thing's going to be, the bells are going to be flashing and the gates are going to be down the whole time. Current detection. This is usually a train is detected when a flow of electric current is across the rails, or is detected as the train goes across it. Okay. And you use this current flow to activate the circuit, to operate flashers and gates, etc. So it requires sections of the track in the vicinity of the grade crossing to be isolated, because obviously anytime there's a train on the tracks, the flow of electricity is from one rail to the other, so there is obviously a flow of electricity at all times. If you have an isolated section, then there would not be a flow in that isolated section. So the train can run all other places in the layout, but it wouldn't be triggering anything because the section that is used to trigger the grade crossing would be isolated. But it also requires metal wheels with resistors on rolling stock so they can be detected. In other words, once the engine is the part that will pick up electricity from one rail, goes through the motor, drives the engine, and goes back through the other rail. But once that leaves that isolated section, the system thinks that the train's gone. So if you still have a train going through with cars on it, the gates are going to go up and the crossbucks are going to stop flashing, and you've still got cars going through the grade crossing. So you need to put metal wheels with resistors that will basically have a flow of electricity across them as they go through that isolated section. The one I like best is the infrared emitter and detector detection system. Infrared light is light that's above the visible spectrum, and we use it every day. Our TV remotes use it, and the like, other remote actuators that we use. And depending upon the placement of the emitter and detector, the train can be detected if either the infrared beam between the emitter and detector is broken or if it's completed. Now, here's an across the track emitter and detector. You see, here's the emitter, and then across the rails on the other side is a detector. So when the train breaks that beam, that infrared beam, okay, that is what is detected by the electronic circuits, and that is what is used to trigger the Crossbuck Flashers or dropping the gates or the like. So in this case, you have an emitter on one side, a detector on the other. The downside of using emitters and detectors that are across the track is that you see them. They've got to be up enough, they got to be up high enough so that a freight car, will block them. In other words, they're not real low, so because then they would be shining underneath the wheels and it wouldn't do any good. So the downside is you got to hide them. Got to find ways to hide them in foliage or in trackside structures. So these are just some examples of what I did. Here's an emitter. Here I put a detector in the back of a building, and I just drilled a hole where the detector would sit. So as you can see, there's a direct line across here. The emitter is kind of buried in this foliage, and the detector is hidden inside the building. And here's one where I've got the emitter. I cut a little hole in this line side shed, so it's projecting through. And then what I did is I built a tie stack, but I made it hollow in the middle, so it covers over the circuit board, and then the detector is just kind of sticking out. And again, the aisle is out here, so the viewer is not looking in and seeing a hole in the end of this because it's at the wrong angle. And just here's another spot where I've just put both the emitter. This is both an emitter and detector are just kind of, they're mounted up on a little plastic short piece of I-beam, actually, and glued on top. And then here I've just got foliage kind of around them, and I paint them, you know, grimy black, so they kind of blend in with everything. So they're not really that noticeable. And then here's another one where the detector's buried in some foliage. And here I put an emitter. I was trying to figure out where I could put it, and I said, well, you know, how about if I had something look like an air conditioning or some kind of piece of machinery that had been delivered and was sitting outside of the building to cover it. So this covers the detector, and I just have a little hole on the end where the emitter pops out. Now, the other way you can fool with emitters and detectors is to put them between the rails, okay? And now when a train passes over the emitter, the infrared beam is reflected off the bottom of the engine or the car to the detector and completes the circuit. So as you can see, in the other way, when they're across the track, what you're doing is you're breaking the beam. In this configuration, the emitter is shining directly up. So it's not incident, the beam, the infrared beam is not incident on the detector until a train goes over it. And then that infrared beam is reflected off the bottom and onto the detector, and that's what activates the circuit. And when you're mounting it, just showing here, this is just where I drilled the holes for mounting the infrared emitter and detector. And then here's the infrared emitter, and this is the detector that are between the rails. So they're really not that noticeable unless you're really looking hard and the like. But remember, they require different circuits. Because in one case, you're detecting a train when the beam is broken, and the other case, you're detecting a train when the beam is not broken. So who makes detection systems that will operate flashers, gates, and bells? You know, I started doing my research again. I came up with Circuitron, Berkshire Junction, ZStuff for trains. There's Arduino circuits, and then there's Logic Rail Technologies, which is in Houston. How about that? Now the Circuitron one, they manufacture a variety of detection circuits to operate just Crossbuck Flashers, as well as flashers, gates, and bells. This is what I found online and looking at their catalog. They have DT1, 2, and 3 circuits, which work on DC only. They don't work on a DCC system. They have a DF2, which uses optical sensors and operates flashers, gates, and a bell. And a DF3, which uses current detection and operates flashers, gates, and a bell. This one requires 3 isolated track sections, and rolling stock must use metal wheels with resistors, as we talked about before, in order to be detected. And when you go on their website, what you find is that the DF2 and the DF3 are not available. So even though it sounds great, you can't get them. Berkshire Junction. They use infrared emitters and detectors that are across the rails. The circuit only controls Crossbuck Flashers. In other words, when you buy their system, you'll get 2 Crossbuck Flashers, a circuit board, and 2 sets of emitters and detectors. But the circuit does include a relay on it. It's a single pole, double throw relay. And you can use that to drive an additional circuit that will operate gates and a bell. But what you have to do is you have to basically take the output of that relay and tie it to a double throw, double pole relay, so you can get it to reverse the polarity of the output voltage. when the double pole, double throw relay flips. And that will change the polarity, which would drive a tortoise machine either one way or the other. It utilizes infrared emitters and detectors on both sides of grade crossings. And the problem is the system only activates when the infrared beam across the train is broken. And that's fine, except if your train is not long enough to break the infrared beam downstream of the grade crossing before it clears the upstream beam, the flashers and bell will stop and the gates will go up while the train's still going through. So in other words, you've got an infrared emitter and detector upstream of the grade crossing. Say it's on HO scale, maybe you put it 1.5 feet, 2 feet away. If it's too far, and let's say you've got a train that's maybe just an engine and a caboose, or an engine and 2 or 3 cars, so it's not that long. As that train approaches the grade crossing, it'll break that beam, it'll start the flashers, the gates will go down. But the trouble is that in order to keep those gates down, you have to also activate the one downstream. And if that train is too short, what will happen is the whole train will clear that upstream beam before it hits the downstream detectors. And so while the train's going through the grade crossing, the gates go up and the bells stop and everything, and the crossbuck stop. And then as soon as it hits the downstream, they'll start up again. You can try and fix that by moving the detectors and emitters closer to the grade crossing, but then that makes them start at a more non-prototypic time. In other words, they'll start up, almost right before the train hits the grade crossing. And what you would like to do is have them start up in advance as the train approaches the grade crossing, just like they would in real life. ZStuff for trains, I talked about that. Their product for HO was DZ-1010HOS. I can't find it listed on their webpage product list, but I've seen it advertised. I'm assuming it operates similar to their S&O gauge crossing gates. I think they may still make these. They use optical detectors. One of the drawbacks is the crossing gates and crossbucks appear to mount on a platform, which I think is housing some kind of a mechanism, a motor. So it doesn't look completely prototypic. And then they do have a circuit board that extends, I think it's about 3 inches below the layout. So if there's anything underneath, you got to make sure you got the clearance. I talked about Arduino circuits. Arduino, it's a company that makes microprocessors that you can program. You can take inputs from photocells or infrared sensors. You can program the Arduino microprocessor to give you output signals that operate flashers and gates. The output on an Arduino, I believe, is like 5 volts. So what you have to do is you have to tie that to a relay that activates on 5 volts, but has contacts then that can handle 12 volts. So you've got to add some additional components in order to get the Arduino circuits to be able to operate, for example, switch machines and stuff. Now, you can make them drive servo motors, which I think operate on 5 volts. But again, I kind of looked into it, and that programming gets a little bit hairy. So unless you really like to get into programming with C++ language and stuff and learning all that, I didn't want to get into it. So it can be done, and there are people that probably would like to do it and enjoy it and stuff. I'm not one, but it is an option. As I said, and once you program your microprocessor on your Arduino board, you can disconnect it and mount it on your layout, and then you connect all the components to it, and you just put a power source to it. Now, the one I like, and I'll talk about, is Logic Rail Technologies, and they are located in Houston, Texas. It appears to be a small company. They make a circuit called Grade Crossing Pro 2. This is sort of a new version of what they used to call the Grade Crossing Pro. And it utilizes photocells, current detection, or infrared sensors that are provided with the version of the GCP2 that you order. Or you can order infrared sensors from another vendor, they say. They use an example of Iowa Scaled Engineering's train spotter. The infrared emitters and detectors can be mounted either between the rails or across the rails. So, but you have to, again, you need to tell them what you want. In other words, if you want something that will be mounted between the rails, it's going to have a certain infrared, a certain microprocessor in it. If you want it across the rails, it'll have a different microprocessor in it. And I'll talk in a minute about the pros and cons of between the rails versus across the rails. But this system detects trains and activates flashers, gate motors, and a crossing bell. They use the same circuit board for all 4 detector types. And the newest one now used to be on the old GCP that you would have to swap out the integrated circuit on it, the microprocessor. Now he's got a bunch of switches on it. So you can just set switches on the circuit board and you configure it to whatever your detector type is. And the latest one, actually, I thought it was neat. They said it has an output for an end of gate LED that doesn't flash. So you can put a, you know, if you really like to get into it, you could have a small LED, a red LED, for example, on the end of your crossing gate that will light up when the gates go down. And they also now added this realistic fading of the Crossbuck Flasher lamps when they're flashing, and it's called True Lamp 2. I've not seen that, but they advertised it on this new GCP2. And the other thing they have now is gate motor outputs that will drive both tortoise switch machines as well as separate ones for servo motors. So you can actually drive a servo motor now off of this GCP2. You don't need to go with the tortoise switch machines. This is fairly new. They have 3 different crossing bells available. They call the classic mechanical bell, the modern electronic bell, and the fast classic mechanical bell. You can go on their website and they actually have recordings you can listen to, so you can see which one you like. But the bells can ring continuously or only when the gates are moving. And so what does this look like? Well, here's the Grade Crossing Pro 2 circuit board. And these are all these configuration switches right here. This is the microprocessor. This is the bell. On the old version, you had a separate bell circuit that had to be connected to it. It was mounted separately. Now they have it where it just plugs into the board, which is convenient, and the like. And these are basically all your inputs and outputs that you use for your infrared detectors and emitters, and then also the outputs for the gates and so forth, and also the Crossbuck Flashers. So here's how you set it up. You put an infrared sensor here. This is, when I say sensor, I mean it's an emitter and detector pair. As you can see, it's, you know, if a train's coming from the left over to the right, you might mount this maybe 2 feet, 2.5 feet from the crossing, grade crossing. And then you mount the second one a little bit closer. This one could maybe be a foot or so away. Again, it's another set of emitters and detectors. And you do the same thing on the downstream side. Maybe about a foot away, you put an emitter and detector pair. And then about 2.5 feet down here, you have an emitter and detector pair. So how does this work? Well, when an eastbound train moving from left to right it'll activate the flashers and bell when the train passes over WF, which is right over here. So when a train covers that will activate and it'll start the flashers and it'll start the gates. Okay. And then it says, I'm sorry, and then after a short delay, the gate motors are activated and then the gates will lower. And the signal continues to flash and the bells ring and gates remain lowered even if the train clears WF. As long as the train passes over WN, you guys hear that? All right, it stopped.
I cleared it. It was someone opened up their mic and it was feeding back.
Okay, yeah. Now W, just so you know the nomenclature, W is like for west, and then F stands for far, and again the E stands for N stands for near. So if you go over here, this is like what they call the west far detector. This would be the west near detector. This is the east near detector, and this is the east far detector, just so you know the nomenclature that they use. But the nice part is that the signal will continue to flash and the bell will continue to ring and the gates remain lowered, even if the train clears WF, as long as the train passes over the WN sensor within 35 seconds. So what we're talking about is the train goes over this one, okay, and it activates, the gates are down, the flashers are going, the bell's ringing. As long as that train covers this one, WN, within 35 seconds, these things will continue. Even if the train clears and uncovers these sensors, those gates will remain down, the bells will remain ringing, and the flashers will keep going until, as long as that train covers this detector, this sensor, within 35 seconds. Now, when the train then passes over the EN sensor, okay, 2 seconds after the last car clears the EN sensor, the gates will raise. So now when the last car goes through the grade crossing and uncovers the EN sensor right there, okay, the gates, after 2 seconds later, the gates will raise, and then 3 seconds later, the flashers and the bell stop. Now, what happens if the train passes over WF but doesn't reach WN within 35 seconds? Let's go back over here. So now I got a train that goes over this WF, but it stops. Let's say they're going to do some switching. There was a siding back here, so they want to stop and then they want to back up and they want to, switch some cars. So it goes over and it activates that sensor, but then it stops, okay, and it doesn't activate this one. Well, it says if the train passes WF but does not reach WN within 35 seconds, the assumption is that the train is reversed. In other words, which it has, it stopped and it's probably gone reverse because it's going to do some switching. And so the flashers and the bell will stop and the gates will raise. And then the system behaves the same for a westbound train. So if you're coming from the other direction, it's going to do the exact same thing I just described when you come from the other direction. Again, if I'm going left to right, I think I'm sorry, I just did this. Where am I? Yeah. Yeah, this does the same thing again when it comes in the other direction. Now, what if I have multiple track grade crossing? Okay, and if you remember back on, I've got a double track on my layout, and so the question is, how's all this work? Okay, well, they make a thing called the GCP2 expander. Okay, and this is what it looks like. And you have to put a sensors in your second track. In other words, if you have two tracks, you hook up one track the way we just talked about with the GCP2, and then you have to put another set of detectors in the rails of the second track, and you hook them up to this expander board. And the expander board will connect to the main board. It's sort of like a slave to the main board. So one expander board is needed for each additional track. So if you have a 4-track crossing, you would need a bunch of these, okay? What this does is it doesn't confuse things. So for example, if you think about it, if I've got if I have an across the track, you know, in other words, it's not embedded in the track, but let's say these detectors were across the track and it was a 2-track. Well, you've got a train coming in from this direction, and then say there's one coming from this direction, okay? Well, now the circuit doesn't know what the hell's going on because it sees this one's triggered and this one's triggered. Okay, so what this whole thing is doing is eliminating that, you know, screwing up your circuit board and confusing it. Because what it does is it says, okay, there's a train coming in on this track, and oh, there's one on this track. And so it sets the logic correctly for keeping these gates down and stuff. So now, but I do want to go back and say that this can get expensive. I have a, if you remember back here, let me see if I can find that picture. It's on here. Yeah, if you look at this crossing I had on my layout, I've got 4 tracks. Okay, and you know, so the question is, you know, am I going to put, you know, a GCP2 and then 3 expander boards and the like, and it's going to get awful expensive real quick. And so what I decided is I said, well, you know, at this area right here, I very rarely have 2 trains crossing at the same time. Even when I have operating sessions, it's very rare I'm going to have 2 trains, one going in this direction and one going in the other. So rather than spend God knows how much buying 3 expander boards and a GCP2 and, you know, all the detectors and all that other stuff, I just put one set of infrared emitters and detectors across both rails, all 4 rails. So now I can detect the train on any track using just one detector, one GCP board. But as I said, if for any reason I were to have a train come in this direction at the same time as one coming on another track in the other direction, it's going to confuse that board, you know, and it'll probably make it do some weird stuff. So anyway, let's go back. So how hard is it to hook up all this stuff? Okay. Well, if you get the GCP2, the instructions are very clear, okay, and not complicated. You read it and it just makes perfect sense. There's nothing to be confused about. There's a lot of diagrams that show you how to hook stuff up, where all the wires go. So you really can't get in trouble, okay? Now, what I found is it's best to mount those circuit boards, like the GCP2 or the expander or whatever, on a piece of plywood. And then I connect all the circuit board terminals to some terminal blocks that are also mounted. It makes it a lot easier. This is because several of the circuit board terminals will require multiple wires connecting to them. There'll be for example, a 12-volt input on the GCP2 board. Well, you're going to have to use 12 volts though for a bunch of the other things. So you really want to have someplace where you can tie into 12 volts without having to put 4 or 5 wires into one of those little small terminal blocks on the GCP2 board. And like I said, connecting the wires to the larger terminal blocks is easier, especially if you're doing this under the layout. You're sitting on your butt looking up and with a flashlight or a clamp on light or something and trying to get everything hooked up. So this may look confusing, but it's not. This is a GCP board. It's not the GCP2. When I first bought this, they didn't have a GCP2. So this is the GCP board, and then this is the speaker, the separate speaker over here. And all this wire and stuff, these are just coming from the detectors. And then here's an expander. This is a GCP2 expander because I have a double track. And as you can see, what I really want, what I really found out is, putting these terminal blocks in here and then connecting all these wires off of the board to it makes hooking everything up so much easier. You can label it, you can see what it is, I just write on it and I say what stuff is and the like. Now remember, there's lots of wires, okay? I can't get around that, okay? Each circuit board has 4 emitters and 4 detectors, okay? 32 sensor wires go into 2 circuit boards, okay? There are 16 sensor wires per track, okay? Remember, you got an emitter and each emitter and detector has 2 wires each, okay? So each sensor emitter detector pair has 4 wires. Okay, so if you have 2 upstream and 2 downstream, that's 16 wires right there you're going to deal with. And then if you've got double track, that's 32 wires. That's just for the sensors. Then you got to have 3 wires to go to each Crossbuck flasher. Okay, and you got 2 Crossbuck flashers. So that's potentially 6 wires that you got to wire there. You got 4 wires to go to 2 switch machines. Obviously, each switch machine takes 2 wires. You got 2 wires to go to the speaker, and then you got 2 wires for the power supply. So it's a bunch of wires. But again, if you just label everything and work slow, it's not a problem, and you really don't. It's not a big deal. Okay, it all works, and it is not difficult. So let's get down to the nuts and bolts. What does all this cost? I think I said before that if you can find the HO scale, NJ International, the combination Crossbuck Flasher and crossing gate pair, even when they were new, I think they ran at the hobby stores around 55 or 60 bucks for a pair. That's what I saw them actually being sold on eBay for. So if you're lucky enough to find them, that's an average price of what they're going to cost. If you go with something, if you make your own, for example, you just buy like the Walthers flashers. The Walthers flashers, by the way, will hook up to the directly up to the Logic Rail Technologies GCP2. But be advised that the Berkshire Junction Crossbucks will not. Okay, they use a different wiring diagram circuitry in there that's unique to their circuit board. Anyway, if you use tortoise switch machines, you'll need 2, 1 for each gate. They're about 15 bucks each on eBay, or sometimes hobby stores are about 20, I think. But I figured about 30 bucks total. If you go at Berkshire Junction, there are infrared detectors, Crossbuck Flasher, and circuit board that will only drive their Crossbuck Flashers. Remember, I just said that they will not drive other Crossbuck Flashers. And their Crossbuck Flashers will not work on other people's systems. But their system is $65 roughly. If you use infrared detectors and a circuit board to drive other manufacturers' Crossbuck Flashers with no gates, and they do have a circuit board that will drive other manufacturers. You don't have to buy their Crossbucks, but theirs is I think $40. The Circuitron DF2 circuit board, they had no price available, and I said it wasn't even available. It wasn't available, but I'm going to guess it's probably going to be a range of 50 bucks. The ZStuff for trains, when it's available, you can get the 2 flashers and the gates that hold integral system for about $152. That's what it was listed at. This says you can get an Arduino starter kit for $91.90. You can get it cheaper. I think they were advertising one in model Railroader for about $35. I got a starter kit for, I think, from Amazon for about $25 or so. But that doesn't include all the other stuff, like you'd need a separate relay, etc., to drive stuff. So I really don't have a good handle for what the Arduino would cost. I know that the servo motors are a lot cheaper. They're about maybe 5 or 10 bucks. I've seen them. And then Logic Rail Technologies, which is the one I kind of like because of the way the board behaves and the way I think it's much more realistic. If you get their GCP2 with the photocell detectors, remember, this is the same thing, that you can't run these things at night. You can't run them with a darkened room. The photocells have to have light from the room. That lists for about 48 bucks. The GCP2 with the infrareds, that's about 60. And then if you just get the GCP2 and you get your own external detectors from somewhere else, that's about $40. If you want to do additional tracks and you want to use the expander circuit, their expander board is, with the infrared sensors, is 50 bucks. Photocell sensors is 38, and if you get your own external sensors, it's about $30. The crossing bell circuit, and I said there are 3 bell sounds available. You pick the one you like or whatever. It's about 20 bucks. And they also sell a 2-inch 8-ohm speaker if you need one for the crossing bell. That's $6, but you can use any speaker. So I said, let's take a look at an operational grade crossing in HO scale. It uses the NJ International combination Crossbuck Flashers and crossing gates, 2 Circuitron tortoise switch machines, and then the Logic Rail Technologies GCP2 with the infrared sensors. This is a single track installation. So the gates and flasher, I said, it's going to be about 60 bucks. This is variable though. I mean, if you bought the Walthers ones, I think you can buy for about $29, the flashers. And then if you just made your own gates or so, then that would be cut in half. Or if you bought like the Tyco ones for 10 bucks or something and put them on the Walthers ones, again, that would only be about $40 instead of 60. The GCP2 infrared circuit's about 60. 2 tortoise switch machines will run you about 30. Crossing bell is 20, and a speaker 6. So the total cost of doing a whole grade crossing with the gates and flasher, the circuit board, the switch machines, crossing bell, etc., is about $176. And then there's also the cost of, there's wire. You got to have a 12-volt power supply. You probably need to get some terminal blocks, and whatever other miscellaneous components, any, soldering spades or whatever. So I'm going to just show, this is on my layout. This is an operational crossing. Uses the, you can see I've got right here the 2 NJ International gates. The detectors are mounted in the rails. There's a train ready to come on here. The first ones are right here. The second ones, I believe, are right about here. And then on the other side, you can't see them, but they're about the same distance downstream. There's a bell somewhere. I don't know where it is. There it is. So now once it clears the detectors on this side, the bell stops, lights go up, and then the flashers stop. So where can I get more information? Here's a bunch of websites. You can probably Google any of these and you'll come up with a website. I don't think you need to write anything down, but NJ International, if you want to see if they ever get their crossing gates back in stock and the like. Berkshire Junction, again, their system's not bad. It's got some limitations though, as I said. Circuitron, like I said, I don't think there's anything available that was worthwhile right now. ZStuff for trains, if they ever get their system back, I imagine it would be fairly easy to put in place. If you want to get into Arduino, that's an option. But it's beyond, like I said, you got to understand how to program in C++ language and hook all that stuff up and the like. And Logic Rail Technologies, which is the one I found to be the easiest to use because the board's all there. It's got all the right bells and whistles and delays and stuff, and behaves in the most realistic way. And the guy who runs the place, Chuck Codsall, I think his name is, very, very helpful. If something goes wrong, if you're hooking it up and it doesn't work right, I don't know how many times I picked up the phone and was on the phone with him. And I had a unique situation is that one of the boards he sent me had a bad microprocessor in it. And I was we were trying to troubleshoot everything but the microprocessor. And so once we discovered it was the microprocessor, he sent me a new one for free, and that solved all my problems on it. It's kind of a rare thing. But again, they're very helpful in terms of providing assistance if you get stuck on something or you have questions. I just pick up the phone and call him, and he usually answers, and very, very, very helpful and friendly. So what do we conclude from all this? Well, I mean, anything that I think that adds animation to your layout is going to add some realism and the like. And automatically activated operational crossbuck flashers, crossing gates, and a bell, I think can add some nice realism to your layout, especially if you have visitors that like to come over and see the trains run and stuff. At the time when I wrote this, I said there was one integral system available for Mike's Train House. I don't, you know, the last time I checked, which was a couple weeks ago, it was not available. So I have to change that slide. I did not find constructing an operational system from separate components very difficult. It's kind of fun, actually. You know, trying to figure out ways to get gates to go up and down, and to kind of kit bash certain crossing gates onto certain crossbucks. I do recommend that you just don't jump into it. Like anything I get into, I do a little of my own research on what's available and their capabilities before I decide on a system and spend any money. My conclusion from all this is I've been very pleased with the logic rail technologies detection and activation circuits. I've got it on, so far I've got it operational on 3 grade crossings, and I had mentioned, I think earlier, someone that I'm installing it right now on my last grade crossing. And I've got everything in place. I just got to go. When I'm done here, I'm probably going to go down and start hooking up the wires to the board and the like. So I've been very pleased with the logic rail system. Seems to work fine, and it does what I want and the like. So, well, when I gave this, this was a clinic I gave at the last convention up in. Where was the last one? Oh, in Hunt Valley, and the like. So, but I think this is posted on our website, and I think this is also going to be on YouTube. Is that right, Ernie? And with that, you guys can unmute, and if you have any questions, and if you got anything, if you come across something, there's my email. Feel free to contact me and the like. And other than that, I'm done. Thank you.